All right, so this is AP Calculus Self-Check 3.3. There are a total of 5 questions on 3.3, which means you gave yourself 10 minutes, and here are the answers. Number 1 is A. Let's talk about why. By the way, today's date is Wednesday, October 16th, 2019. So we have this function, and notice that all of our possible options are increasing or decreasing for f. So let me ask you, is f, or what is f increasing? F increasing, the definition, and what is f decreasing? You should know these by heart by now. F increasing is f prime positive, or where f prime is greater than 0, and f decreasing is where f prime is negative, or where it's less than 0. So we need to find f prime, and then we're going to see if it's positive or negative for those intervals. So here we go. F prime of x is equal to, the 3 is going to come down in front, and it's going to be 3x, and then it's going to go from 3 minus 1, which is 2, minus 12, and then 24 is a constant, so there is nothing there. Now we need to set this thing equal to 0 to find where it's greater than 0 or less than 0, so essentially we're finding the critical values now. So let me switch to a different color. We are now saying that 0 is going to be set equal to 3, and I can actually factor this one a little bit more. So I'm going to say, if I factor this guy a little bit, it's going to be 3 times the quantity of x squared minus 4. And you can factor it a step further because you say, oh, that's a square because x squared, and oh, 4 is also a square. This is a difference of squares, which factors to, we still have that 3 out front, x plus 2 times x minus 2. You have this conjugate pair here. Both of these, by the way, are to the power of 1. You don't need to write that, but it definitely helps when you're doing your switching over your critical values. So if I say 0 is equal to 3 times x plus 2 to the power of 1 times x minus 2 to the power of 1 again, I need to use the zero product property to say, well, this thing could be 0, so that means x could be negative 2, or this thing could be 0. Let's switch to black here. This x minus 2 could be 0, so that means x is equal to positive 2. I don't know why I said x is, let me come back here. And so that means x is equal to negative 2, and over here we have x is equal to positive 2. So those are the two critical values, and I can label those. Those are our CVs. So I'm going to make my number line, and I'm going to mark up my number line and say I have negative 2 and positive 2. I know that because my critical value of negative 2 and positive 2 both came from these two linear pairs, that means I have an exponent of 1, so it will switch values over these critical values. It won't say the same value. So let's choose the easiest possible number to plug in. I think 0 is the easiest number to plug in. So if I plug in 0, it's going to be 3, which is positive, so I have a positive times, when I plug in 0 here, it's going to be 2, which is a positive, so I have a positive times a positive, and 0 minus 2 is a negative. So I have a positive times a negative, which means I have a negative down here. So this is going to be a negative, and therefore that means this is f decreasing. And because I know that this is going to switch signs over these critical values, because I have odd powers, this is going to be a positive, and this is going to be a positive, and therefore this is f increasing, and this is f increasing. Again, if you don't believe me, you can just plug in a test value over here. You can plug in 3 and see that everything is going to be positive. If I plug in negative 4 or something, I'm going to get a negative times this positive 3, which is a positive, and I will get those same intervals. So let's come back through here. Increasing for x is less than negative 2. Well, it is increasing for x is less than negative 2. And decreasing between negative 2 and 2. So between negative 2 and 2, it is indeed decreasing, and it is increasing for x is greater than 2. Everything from here to the right, it is increasing. You don't want to say it's any of these because they're all wrong. All right, so number 2. The derivative of f is that, oh, we already have the derivative. Nice and easy. I'm looking for where I have a relative maximum. So here's your question. What is the definition of the function relative maximum? And the definition is where f prime has a sign change. well, I guess a sign change from, I don't have to write that out, a sign change from positive to negative. If it was just a sign change, it would purely be a relative extremum, but since it's a maximum, it's positive to negative. So I need to go ahead and graph this thing. Before I even make my x-axis, and I should have labeled this with x, notice that this is an odd power, sorry, an even power. This is an odd power, and this is an odd power, which means this, whatever critical value, which is 0, that's going to come from this x to the power 4, will not switch signs when I jump over that critical value of 0. But I will switch signs because these both have odd powers. It will switch over 2 and it will switch over -3. So something to keep track of as we're moving through this problem. When I graph my x-axis, I will label it x this time. My critical values are pretty straightforward. They are 0, that comes from this critical value, 2, which comes from this linear pair, and then this linear pair gives me x is equal to -3, so -3. Again, I'm using the zero product property. I'm saying each of these is equal to 0, and then I'm solving for x. So I'm going to choose the nicest value to plug in. The nicest value that I think of is 1. If I plug in 1 into each and every one of these, that means I'm going to have 1 to the power 4, which is a positive, 1 minus 2, which is -1, which is a negative, and 1 plus 3 is 4, which is a positive. A positive times a negative times a positive is a negative, which means on this interval I have a negative value, which means this is f decreasing. The shortcut, again, is when I hop over this critical value, because this critical value came from x to the power 4, which is an even power, I am not going to switch signs. This is going to stay negative, which means I have another f decreasing. I am going to switch values over this critical value because this 2 came from x minus 2, which is to the power of a odd, so this is going to be a positive over here, and for the same reason this is going to be a positive because this is an odd power for that linear pair. That means I'm going to have f increasing and f increasing. From there, I need to find where I have a relative maximum, so that goes from a positive to a negative. I didn't even need to label any of those. I could have crossed them all out. Oh well. A relative maximum is positive to a negative. You always read from left to right. This one doesn't count because it goes from negative to positive. I don't read backward. The only maximum I have is at -3. I only have one relative maximum. So the correct answer here is B. Number 3. The correct answer for number 3 was E. Let's talk about why. The graph is concave down. All right, so what is the definition of function concave down? The definition is where f double prime is less than 0. So this is the second derivative test, which means I need the second derivative. So here comes the first derivative. I'm going to say, I can just say y prime for the first derivative. Y prime, the 4 is going to be multiplied down. 4 times 3 is 12. X to the power of, it used to be 4, subtract 1, it becomes 3. This is the powerhouse rule. And I'm going to subtract 3 times 16, that's going to be 48. X, it was to the power of 3, subtract 1 goes to the power of 2. And I'm going to add, 2 comes down, multiplies to 24, so 48 again. X to the power of 1 because I subtract. And this is going to be 48, that's a constant, it goes away. There is my first derivative. Let's take the second derivative as well, do that in a second color. I don't have to play with the first derivative. I don't need him at all. I'm only dealing with f double prime because that is the definition of f concave down. Y double prime here, so 3 times 12 is 36, x to the power of 2, it goes down from 3, minus, this is going to be 96x, and then plus 48 with no x, because it's x to the power of 0, which cancels out. I'm just left with 48. So there's my second derivative. I now need to set it equal to 0 and solve. So unfortunately, this thing looks kind of ugly, so let's go ahead and factor out the greatest common factor, and then hopefully factor that quadratic. Using Advanced Ninja Star. So I see that each of these has, I think, 18. Does 18 go into 48? No, it does not. Do each of them have 12? 12 is the number I'm looking for. There you go, Mr. Sindel. So 12 times 3 is 36. Yes, all of that works out. And let me just, yeah. So if I factor out a 12, I'm going to be left with 3x squared minus, I think 8 times 12 is 96. So minus 8x. And then plus 4. All right, and I can factor this thing yet again, so this is going to be equal to 12 times, and then this is going to be using Advanced Ninja Star, if you remember that. So Advanced Ninja Star is where I multiply the far left and the far right, the A and the C, I guess. 3 times 4 is 12. And then I have -8 on the bottom, and because it's Advanced Ninja Star, I have 3x here, 3x here. The question is, what two numbers multiply to 12 and add to -8? Well, 3 and 4 multiply to 12, but they don't add to -8. 6 and 2. Oh, -6 and -2. There we go. -6 and -2. And then I have to reduce these fractions. So 3x over -2 can't be reduced, but 3x over -6 can be reduced to x over -2. And there are our factors. X minus 2 and 3x minus 2 will give me 3x squared minus 8x plus 4. So coming back down here, this is now going to be x minus 2 times the quantity of 3x minus 2, 3x minus 2. Perfect. I have the second derivative. Now I need to set it equal to 0, and then I will find the possible inflection points, but mainly I need to see where it's concave down, so I do need to set this equal to 0. So coming down here, let's switch to, what color have I not used? Red. 0 is now going to be equal to 12 times x minus 2 times 3x minus 2. 12 can never be 0, but using the zero product property, I know that this will give me a possible inflection point of x is equal to positive 2, and this will give me a possible inflection point of positive 2/3. X is equal to positive 2/3. So we need to graph these on our number line over here. Running out of room. I think we have enough room though. This is our x-axis, our possible inflection points. We have 2/3 right here, 2/3, and 2 is right here. And then we need to check the signs. Notice that both of these are odd powers for their linear pairs, which means I will be changing the sign over each of these possible inflection points. So let's find the easiest value. I think the easiest value for me at least is over here at 0. So if I plug in 0, 12 is still positive, 0 minus 2 is negative, and then 0 is going to be, 3 times 0 is 0 minus 2 is negative, so I have a positive times a negative, which is a positive overall, which means coming down here I'm going to have a positive value, which means this is concave up. And the question is asking for concave down. I know I'm going to switch signs over this. It is going to be an inflection point because I have an odd power for this linear pair. This possible inflection point, which actually is an inflection point, is coming from this linear pair. I am looking at this odd power. It is going to be a negative, which means I have concave down. And this is going to be a positive, so it's going to be concave up. And the question is asking for concave down, which is in between 2/3 and 2. That is how I write it. We're on to number 4. All right, so if f is the function defined by that crazy polynomial, I need to find the possible inflection points, or the inflection points, not the possible inflection points, the actual inflection points. So what is the definition of function inflection point? It is f double prime sign change. If you do not have these memorized yet, go to your speed sheet and work on that. So I'm looking for f double prime. I'm given f. I need to take the derivative and then take the derivative yet again. So f prime of x, taking the first derivative, the 7 multiplies down, and then the 7s will actually cancel out if I have a 7 there and a 7 there. So I'm just left with 5x with no denominator, and it was to the power of 7, minus 1 is to the power of 6, plus 6 times 4 is 24, x to the power, it used to be 6, now it is 5, plus 5 times 6 is 30, x to the power of, it used to be 5 minus 1 is 4, plus, and then this was 1x to the power of 1, 1 times 1 is 1, x to the power of 1 turns into x to the power of 0, which is 0, this just turns into 1. And then from there, the constant is not part of the derivative. The derivative of any constant is always 0. So I've taken the first derivative. Now I will be taking the second derivative. Am I matching colors up here? Let's go with green. So f double prime of x. I'm taking the derivative yet again. 6 times 5 is 30x. Subtract 1, I get 5 here. Plus 24 times 5, that is 120. X to the power of, subtract 1, you get 4. 4 times 3 is another 120. Interesting. x to the power of 3, and then that's a constant, it goes away. So I have the second derivative. I need to factor it a little bit more. I think I switched to black up here. I did indeed. So this is going to be equal to, it looks like 30 is going into each of these for the coefficients, and the smallest exponent is x to the power of 3. So the greatest common factor of all three of these is 30x to the power of 3. What is left over when I factor out the GCF? I have x to the power of 2 plus 4x, and this is getting a little bit messy, let me write a little bit neater, plus 4x plus 4. Perfect, and that can be factored yet again because I can use Ninja Star on this guy. This is going to be 30x to the power of 4, which is still out front, and I can Ninja Star this in my head. This is x plus 2 times x plus 2, which is just x plus 2 quantity squared. Oh, look at that. That's not an odd, that's an even, so I know it's not going to switch signs over there. In fact, that is not a good sign because I'm looking for the x-coordinates of the points of inflection. It looks like I'm not having any points of inflection. Did I make... haha. I did make a mistake. There's my mistake. If you caught it before I did, you may give yourself an extra credit point. This was to the power of 3 and I copied down power of 4 for whatever reason. So this linear, it's not even a linear pair, is it? I don't even know what the definition of this thing is. But this thing, whatever it is called, it is to the power of 2, which is an even. Evens will mean I do not switch signs, so this will not give me an inflection point because I need to change the sign for an inflection point. So, no IP there. I can even label it. No IP. No inflection point. And it's because it's even. Because even power, or even exponent, is even better. Even exponent. But this one will give us an inflection point right here. And I guess I'll stay with the color black. No, I'm switching. I need to be colorful. Yellow, there it is. And I'm going to say this one is going to have an inflection point. There, yes. Yes, inflection point. And why? Because odd exponent. So I'm not even going to deal with that guy. I'm going to pretend he doesn't exist. So this thing I'm going to set equal to 0. And when I do that, I'm going to get x is equal to 0. And that is the only inflection point, so the correct answer here is B. Moving on to number 5. So, fractions. We hate fractions. And I have a variable in the numerator and denominator. I need to use quotient rule, I'm guessing. Yes, I do. Okay, so all of the multiple choices asking us increasing or decreasing, so you need to give me both definitions. F increasing. What is the definition of f increasing? It's where f prime is greater than 0. What is the definition of f decreasing? It's where f prime is less than 0. Both of them deal with f prime, which means I need to find f prime. This is a quotient. I need to use quotient rule. A review of quotient rule. Quotient rule. If you forgot, it's your little, I always think of Snow White when I sing this. It's low d high minus high d low, all divided by low or low squared. And I do like color coding this, so I'm going to make that side green and I'll make the operations black. And that way we can see what's going on. Sure, let's just add another color. Why not? Because I like colors. So when I do that, my high is natural log of x. My low is x, so here we go. When I take the derivative, do I have room down here? I have plenty of room. So f prime, and is of x, of course, of x, is going to be equal to low. Low is just x, the denominator, times the derivative of the top. So times the derivative of log house is 1 over the inner. The inner is just x, so 1 over x. 1 over x. And then I'm going to subtract using black. I'm color coordinating here. Now I'm onto the green. I'm onto high. The high is natural log of x, so natural log of x. And this, I need to be neater in my handwriting. I know. I'll get better. Natural log of x times the derivative of low. The derivative of x is just 1, so times 1. And all of this is going to be divided by, and I just really want to make that black to make my operations all consistent. So all of this is going to be divided by low. So low is just x, so x quantity squared, or just x squared. I'll just leave it x squared. That looks better. All right, now I need to simplify this thing, and I'm just going to switch to red, combine all the colors. So this is now going to be equal to 1 over x is just 1. Natural log of x times 1 is just natural log of x. So 1 minus natural log of x, all divided by x squared. All right, so I need to find where this thing is increasing or where it's decreasing. So I need to first find its critical values. And the critical values are a little bit difficult, so let's go ahead and define those again. So critical values. In fact, I'm not going to define it like that. I'm going to say just FCV. FCV. What is the definition of the function critical values? It's where f prime is equal to 0 or where f prime does not exist. Because f prime is equal to 0, that will give us where the top or the numerator is equal to 0 and does not exist. That's where the bottom is set equal to 0 or the denominator is set equal to 0. So I need to set both the top and the bottom equal to 0, and that will give me all of my possible critical values. So here we go, switching back to blue. When I set the top equal to 0, I get 1 minus natural log of x is set equal to 0. And I'm going to add a natural log of x to both sides. I'm allowed to do that because it's okay. I'm not having any domain errors or anything. So this is going to be natural log of x. And where does natural log of x equal to 1? Natural log of e is equal to 1. And if you don't believe me, you can always check on your calculators. Natural log of e, that's not e, is equal to 1. Ha, ha, ha. All right, so therefore, we can say down here, x is equal to e. That is one of the critical values. And if you don't know what e is, that means, I'll just write this here, e is approximately equal to 2.718. That's a good way of thinking about it. Or if you just prefer 3. Pi, e, they're all roughly 3, somewhere around there. Now let's do the bottom set equal to 0. So if I set x squared equal to 0, that means x is equal to 0. Okay, so I have two critical values. Now I have to find where it's increasing and decreasing. Let's go ahead and make our number line. So there is our number line, and we need to start marking that one up. So obviously 0 comes first, so there's our critical value at 0, and then our next critical value, CV, is at E. All right, so now I need to plug in a nice number. Well, 1 is in between 0 and 2.718. That's going to be my test point. So I'm going to say 1 is my test point. When I plug in 1 into our derivative right here, natural log of 1. Now you need to know what natural log of 1 is. Natural log of 1 should be 0. And if you have anything less than 1, it should be a negative value. So when I plug in 1 here, natural log of 1, I'll write this up here if you forget, natural log of 1 is equal to 0. So it's going to be 1 minus 0, which is positive on the top. And on the bottom, if I plug in 1, 1 squared is also positive. So positive divided by positive is indeed a positive. So I should have a positive value right here, which means this is f increasing. And notice that E, this right here, this whole thing is to the power of 1. That's how I think about it. So if it's the power of 1, it's an odd. It will switch values over here to a negative, which means it is f decreasing. Is that true? Let me double check that work. If you're not sure, this is what you do. You just plug in another value. So my next value that I'm going to plug in is, I don't know, what's bigger than 2.718? 3 is bigger than 2.718. So if I plug in 3, natural log of 3 is slightly bigger than 1, because I know if I plug in E, I get 1. So if I plug in a slightly bigger number, I should get out a slightly bigger number. So I should get slightly bigger than 1. 1 minus a number slightly bigger than 1 is negative. So I get a negative on the top. The bottom is always going to be positive. I do indeed have a negative down here for this interval. So from there, oh yeah, you might be asking, wait, you forgot over here. Well, you can't plug in numbers that are negative. Like if you plug in -1, for example, natural log of -1, you'll get a domain error. Let me see what my calculator does on just Spotlight search. Natural log of -1. Yeah, it's not even going to do it for calculator because it knows it's an error. Just to show you that this does not work, if I go to my calculator, come on Desmos, natural log of -1, undefined. You're not allowed to put in a negative value, so I'm going to say undefined over here. Undefined. So let's go ahead and look at our possible choices. We should be decreasing for all values greater than E, so it looks like that one is definitely correct. Any of these good? No, it says decreasing. That's the wrong interval. None of these are good. Yeah, so the correct answer is just E, and that concludes self-check 3.3. Next, we have self-check 3.4. So now that we're on to self-check 3.4, you should have given yourself 10 minutes because there were 5 questions. We're averaging 2 per minute, or 2 per question, 2 minutes per question. So here we go. We have the graph of this guy, our possible choices, increasing, decreasing. All right, so it's always talking about F increasing and F decreasing. So what is the definition of F increasing? The definition of F increasing is where F prime is greater than 0, where F prime is positive. And F decreasing, the definition of that is where F prime is less than 0, where it is negative. So both of these deal with F prime, which means I need to take or find the derivative. Where is the derivative? So I'm just going to say Y prime in this case. Y prime is equal to, and I'm taking the derivative, 3 times 2 becomes 6, x to the power of it's 3, subtract 1 becomes 2, just powerhouse again, plus 24, and minus 18, that's a constant. Whenever you take the derivative of a constant, it's 0, so we have the derivative. Now we need to find where this thing is equal to 0, but before we do that, we need to factor this guy a little bit more. So if I factor this thing, I think the greatest common factor is indeed 6, so it's going to be x squared plus 4. Ooh, okay, so this is kind of a cool problem. So when I set this thing equal to 0, I don't even need to do that. I can stop right here, and I'll tell you why. We're going to find where things are positive and negative, right? Where it's increasing, where it's decreasing. I need to find where this is positive or negative. Well, I know that 6 is always a positive, so that one's positive. Obviously, it's not a negative 6, it's a positive 6. And this thing is always positive. I will write it out here. Always positive. Why? Why is the thing always positive? Well, I know that x squared is always positive because a negative times a negative is always a positive. Positive times positive is always a positive. And if I'm adding something to a positive, I'm just going to be even more positive. So I'm always going to have a positive. I can never have a negative value. I can never be decreasing. I can only be increasing. So it is increasing for all values of x, A. Number 2. Oh, I love questions like number 2. Relative extrema, again, we need to find the definition or remember the definition of relative extrema, and then you'll see why it's such a nice problem. It gave us the derivative, but you do need to know the definition. So what is the definition of a function relative extrema? The definition is where f prime has a sign change. F prime sign change. So I need to find f prime. Oh, they did it for us. How nice. And I need to find a sign change. A sign change will happen wherever I have an odd power. This is a power of 1, power of 1, power of 2, power of 3. A sign change happens at that critical value and at that critical value. So it happens at 2 and 4, at 2 and at 4. It's that easy. I mean, you could do it the long way if you wanted, but I'm going to do it the shortcut way because it's so easy. So it should be at positive 2, positive 4, so 1 and 3 only. Correct answer is C. Sign change. So I'll write it out. Sign change for any odd exponent. All right, on to number 3. So we have this function. We were looking for where it is concave up. So I'm asking you, what is the definition of the function concave up? The definition of concave up is where f double prime is greater than 0. So I need to find the second derivative, and I'm only given the original function. So I need to first find the first derivative and take the derivative of that. So f prime of x. This is going to be equal to, the 3 comes down, and it's going to be 3x. 3 minus 1 is 2, minus 2 times 6 is 12, comes down a power to the power of 1. Now I need to take the derivative yet again, so this is going to be f double prime of x. That is not the best double prime I've written. F double prime of x is now equal to 2 times 3 is 6x to the power of 1 minus 12. All right, so from here, I need to find where it's concave up, so I'm going to factor this, set it equal to 0, and find where it's positive and negative. So if I factor this, it's going to be 6 times x minus 2. I'm going to set that equal to 0 now. So 0 is being set equal to 6 times the quantity of x minus 2. Obviously, 6 cannot be 0. Only x minus 2 can be 0, and that will give us x is equal to 2. That is the possible inflection point. So when I graph that on my number line, let's graph it right here. Shoink. When I graph that on my number line, my possible inflection point is 2. And I know it's an actual inflection point because it's to an odd power. So I'm going to choose a nice number. The nicest number I can think of is 0. When I choose 0, 0 minus 2 is a negative. This is always a positive. Positive times a negative is a negative. I know that I have a negative interval over here, which means I have f is, I don't even need to say f. I know it's f. It's going to be concave down. And because it's going to switch over here, it's going to be positive. Again, if you didn't catch that, this is an odd power, so over this point it is going to switch signs for the second derivative, and this is therefore going to be concave up. The question is asking us, where is it concave up? It's concave up everything bigger than 2. I say that by saying x is greater than 2. We're on to number 4. If f is defined by that function, I need to find the inflection points. So give me the definition. The function inflection points. What is the definition? It's where f double prime has a sign change. So I need to find f double prime, and I'm only given f. I'm taking the derivative and the derivative on top of that. So f prime of x is going to be equal to 5 times 3 is 15. X to the power of it was 5. Now it's 4 minus 5 times 4 is 20. X to the power of 3. All right, so now I'm going to factor this thing. Oh, no. Don't factor this thing yet, Mr. Sindel. I need to take the derivative yet again. There I go. F prime of x, f double prime of x is equal to 4 times 15 is 60. X to the power of, subtract 1, I get 3, minus 60, x subtract 1, I get 2. Now I can factor this thing. Oh, that's way easier to factor. This thing is going to be equal to 60x squared times the quantity of x minus 1. All right, I'm going to set this equal to 0 and find the possible inflection points. Okay, shortcut time. This is to the power of 1. This is the power of 2. This will not give you inflections because this is an even power. Even powers will never give you a relative extremum, and they will never give you an inflection point. Since we're talking about the second derivative, that is not an inflection point. And I will write out the reasoning in our notes so we have them. Not an IP. Why? Because even exponent. This is an inflection point. So we'll say this, yes. Yes, it is an inflection point. Why? Because odd exponent. When I set this thing equal to 0, I'm going to get x is equal to 1. So the correct answer here is C, only 1. X equals 1. All right, not 0. From here, we are going to go to number 5, our final problem for self-check 3.4, the last of our self-check problems. Ooh, they give us the first derivative and the second derivative, and they're asking us a bunch of questions. This is kind of a double question. It's asking you the definition of f increasing, decreasing, concave up, concave down. They're very similar definitions. Let us list all 4. So, what is the definition of f increasing? F increasing is where f prime is greater than 0. What about f decreasing? Where's the function decreasing? That's not the best e there. There's a better e. F decreasing, that's where f prime is less than 0. What about f concave up? It's concave up where f double prime is less than 0 and greater than 0, Mr. Sindel. And f concave down where f double prime is less than 0. Very similar definitions. All right, so they gave us f prime, they gave us f double prime. We need to now figure out where all of the critical values are and possible inflection points are. So to find critical values, we set the top equal to 0 and the bottom equal to 0 because the definition of FCV, that's where I have f prime is equal to 0 or where I have f prime does not exist. So for f prime equals 0, that's where the top is set equal to 0, and that's going to be natural log of x is equal to 0. Natural log of x is equal to 0. And that only happens at 1. Natural log of 1 will give you 0, so x is 1. So for f prime does not exist, I set the denominator equal to 0. The bottom, set the bottom to 0. And that's just x equals 0. So if I make my mini number line, because I have to do it over here for f double prime as well, for f prime, here's my number line. I have my x-axis right here, and I have my two critical values at 0 and 1. Notice that this is all natural log of x is to the power of 1, so it's going to switch over both of these values. I have natural log of x, so this one, it's undefined over here, so I'm just going to say undefined over here. Between 0 and 1, what's happening? Yeah, well, whatever. I'll choose a bad number, like a half. I have to. Oh, no, I don't have to. Let's choose E. And let me switch colors here. Let's choose E, because E is a nice number. E is about 3, again, 2.718. If I choose E, natural log of E is going to be 1. So on the top, I'm going to have positive. On the bottom, I'm going to have E, which is also positive. Positive divided by positive is a positive. So this down here is going to be positive, which means we have increasing. I'm going to say increasing, or f increasing, and it's going to switch over here, so it's going to be negative, which means I'm going to have decreasing, because if you don't see a power, just assume that it's to the power of 1. So, and it's saying, let's see, which of these can we eliminate? So we need to say it's decreasing if it's between 0 and 1. So decreasing for x is greater than 1. No, it's increasing. Decreasing for greater than 1. No, it's increasing. F is increasing. Yes, that's correct. Correct. Increasing between 0 and E. No, it's not. It's only increasing when it's bigger than 1. So it's between C and D now. All right, you guys are about to arrive. I need to go fast. The graph is concave down or concave up for x is greater than E. We need to determine that really quickly. So I need to find where this thing has possible inflection points. So again, I need to set the top and bottom equal to 0. So I'm going to write this possible IPs. The way that I do that is I set, I guess the definition that you need again is where f, it's a sign change, but possible IPs is the equivalent of an FCV. It's where f double prime is equal to 0, or where f double prime does not exist. Very similarly, f double prime is equal to 0. That's where the top of the second derivative is equal to 0, which means I'm going to come up here, 1 minus natural log of x. 1 minus natural log of x is going to be set equal to 0. When I add natural log of x to both sides, I get 1 is equal to the natural log of x. And what equals 1 for natural log of x? Natural log of e will give you 1, so x is equal to e. And we don't even need to worry about the second derivative does not exist, x squared, because this will give us, I guess I'll just run through it. Bottom is equal to 0. That means x squared is equal to 0. That means x is equal to 0. But we don't care about that because notice that all of this is only asking about e. So making my quick number line, I can finish here in like 30 seconds, I think. My number line for x. My possible inflection points happen at 0 and e. And both of them are, oh, this one is to the power of 2, so it's going to stay the same sign, but I can't even plug in anything over here because I can't do a natural log of a negative number. This is undefined. When I plug in a number in between 0 and e, like 1, I know what happens when I plug in 1, I get 0. So when I plug in 1, natural log of 1 is 0, 1 minus 0 is positive. And this is always going to be a positive on the bottom, which means I have a positive in this interval. A positive means I'm concave up. Concave up, and it's going to switch over e because this right here is to the power of 1. Odd powers are going to switch. This is going to be an inflection point. This is going to be concave down, and we have our answer. It is concave down. The correct answer is C. It is concave down, and that concludes self-check 3.4.